Alright, so when you use the word molar, the adjective molar, in front of something, that means the value per mole. So if you want the molar mass of anything, then you just need the mass of 1 mole of that thing. So if you want the molar mass of anything, you just need to know the mass divided by the number of moles. Okay, so molar mass would be mass divided by number of moles. If you're dealing with an ideal gas, you know you have a way of finding the number of moles, which is P, you just use the ideal gas equation. Number of moles is PV over RT. So, if you want to determine the molar mass of a pure sample of a gas, all you have to do is you need to have a way of measuring the mass, the pressure, the volume, and the temperature. Okay? So, let's look at a simple example here. Let's say you have an unknown gas, and you find out the mass of that gas to be 0.8802. And using pressure, volume, temperature measurements, let's say you found that it contains 0.0200 moles of gas particles. What's the molar mass of the unknown gas? Then you say molar mass is mass over number of moles. Our mass is 0.8802 grams divided by 0.0200 moles. And that gives us 0.8802 divided by 0.02, 44.01 grams per mole. Okay? Now, let's say you have an unknown gas that has a mass of 0.140 grams and it occupies a volume of 153.1 mils at 373 Kelvin at 1 atmosphere. Which of these is a possible identity of the compound? Okay, so you have 3 choices here. Obviously, these all have different molar masses. If you figure out the molar mass for methane, that's going to be approximately 12 plus 4 times 1. So this is going to be about 16. Carbon monoxide is going to be 12 plus 16 approximately. So molar mass there is approximately going to be 28. Cl2, 35.45 times 2. So you're looking at a molar mass of approximately 71. Okay, so all you have to do is figure out the molar mass based on the information given here to figure out what the possible identity is of the gas. So you say molar mass is mass over number of moles. We're given the mass 0.140, right? And number of moles is just PV over RT. Okay, so let's go ahead and do that. Molar mass is mass, which is given to us as 0.140 grams, divided by pressure is 1 atmosphere, volume is 153.1 mils, milliliters, so I have to change that to liters, so times 10 to the negative 3 liters, divided by R, 0.08206 liter times atmosphere per mole Kelvin, and our temperature is 373 Kelvin. Okay, so Kelvin cancels out, atmosphere cancels out, liter cancels out, so you have your moles for your denominator. So this is grams per mole. Let's just solve for the numerator and the denominators. For the denominator separately first. So you have 1 times 153.1 times 10 to the negative third divided by 0.08206 divided by 373. So your denominator is 0.005002. I'll have 4 sig figs there. That would be the number of moles. And my numerator is 0.140 grams. So I have 0.140 divided by 0.005002. I get 27.988, so 3 sig figs. It's going to be 28.0 grams per mole. Okay, so possible identity of the compound then is carbon monoxide.